At Warwick Control Technologies, we offer an NMEA2000 protocol stack kit. This can aid in the rapid or faster development of NMEA2000 devices due to the fact that it is constructed in such a manner to be able to pass the NMEA2000 conformance test for all mandatory PGNs out of the box with very little alteration. So for PGNs like address claim, product information and configuration information, it's just a case of changing variables to the wanted value for the SPNs or signal values within the mentioned PGNs. So let's take a look at what the presentation will cover. We shall give a brief overview of the Warwick Control NMEA2000 products and services, then describe the NMEA2000 protocol in a nutshell, along with describing the functionality of the multi-packet messaging like fast packet and connection management data transfer, explain why to choose the Warwick Control stack kit due to the out-of-the-box NMEA2000 service support. As mentioned, there is very little work to do with the stack to pass the NMEA2000 conformance test out of the box for the mandatory PGNs. Explain what the NMEA2000 protocol stack kit contains and the breakdown and the benefits of the components, as well as talk of the engineering service offered for house creations for customers and the testing and certification for the NMEA2000 device. At Warwick Control, we provide a range of NMEA2000's products and services, from the NMEA2000 CAN bus analysis tools for the electrical signals with the picoscope, and then the data contained within these messages and signals with X-Analyzer 3 and a Cavassa interface, through to a combined NMEA2000 and J1939 protocol stack kit to speed up developing a device, to then offering NMEA2000 testing and certification of a device with technical feedback on any failures. We shall now showcase the Warwick Control NMEA2000 protocol stack and kit. For anybody new to the industry or becoming multidisciplined, the NMEA2000 protocol is based on the ISO 11783 and the J1939 protocols, due to the fact it uses extended CAN identifiers and has the address claim process, and is of course based at source on CAN, so ISO 11898. Look at our troubleshooting the NMEA2000 CAN bus for a simplified explanation of CAN or controller area network and how it relates to NMEA2000. However, NMEA2000 has a conformance test and uses parts of the J1939 protocol that are used less in the truck and bus industry, like dynamic address claim, where devices communicate for who claims a source address if there is contention between the source address, as well as commanded addressed, where a broadcast announce message or BAM can be sent to command or demand a device changes its source address to a source address value specified within the BAM, as well as the connection management data transfer CMDT with request to send and clear to send for node-to-node communication. There is also the addition of the fast packet protocol in NMEA2000. Like CMDT, it is a multi-packet method. Remember, with CAN, no message can be above 8 bytes long, so these multi-packet methods use a protocol, a language, or a process to send multiple 8-byte CAN messages that can be decoded as one long message due to the sequencing in the messages, or with CMDT having communication between two devices with requesting to send and clearing to send large chunks of data. Let's take a look at the kit contents and benefits. So what's included in the kit? Let's take a look item by item. The C file source code. The C code that contains the already constructed workings of the NMEA2000 protocol, saving the time in creating your own. X-Analyzer 3 Professional. This NMEA2000 and J1939 analysis tool, which also supports CANopen, LIN and CANFD, is our flagship software and is very useful for understanding the developing device's NMEA2000 message communication, as well as the embedded NMEA2000 signal decoding and message building. Then there's Cavassa Leaf Lite version 2, Cavassa's most popular interface, licensed to the X-Analyzer 3 software. Then there's the STM32 development board, The development board comes with a CAN shield and a D9 connector for the CAN bus, as well as a USB lead supplied to flash the C code onto the board and power the development board for use as a reference design. Then supplied with a USB with the relevant files and software and instructions to get you up and running. So what benefits does the NMEA2000 stack kit bring? The C file source code is already developed for NMEA2000 functionality, like multi-packet messages, and out-of-the-box NMEA2000 certification for mandatory PGNs. We shall talk more about this shortly. There's the X-Analyzer 3 Professional. This ensures you are not working blind and can analyze the NMEA2000 message communication, plot and view message signals, as well as easily build NMEA2000 messages in single frame and fast packet format to communicate and test your device while developing. Please see our troubleshooting video for more information on the benefits of X-Analyzer 3. Then there's a Kavasa Leaf Lite version 2, the hardware to send and receive messages from a world-renowned CAN interface manufacturer. There's the STM32 development board, delivered with the C code flashed, so you can use this as a reference design for your product. Then the Warwick Control USB with files, software and instructions to get you up and running. So the main benefits the kit option brings is you have all you need to get up and running to develop the device in less time, a reference design on the STM32 Nucleo board as a starting point, the ability to test and analyze further development with NMEA2000 message analysis, i.e. talk to the development board with X-Analyzer, and it also makes it easier to port the code to your own target hardware. Here's a top layer breakdown of how the connection management data transfer multi-packet protocol works. Put simply, a device will send a request to send message to another device under 8 bytes long. If the device receiving supports the PGN contained in the request and supports the RTS/CTS message packaging, it will send a clear to send message under 8 bytes long. The original request contains the total message size in bytes, how many frames will be transmitted, and as said, the PGN that is wanting to be sent. So once the first clear to send is sent, the original requesting device can then send the first data transfer. Then the receiving device will clear another data transfer, all the time telling the data transferring device how many frames can be sent and the number of the next frame it expects to see. Once all the messages have been received in accordance with the message communication in the RTS/CTS, the receiving device completes the communication with an end of message frame, stating the total number of messages and bytes received. There are also time constraints for CMDT, i.e. a clear to send must be received within 250 milliseconds of the request to send. Then moving on, the fast packet protocol is much simpler. It's just one-way communication. The first 2 bytes of the first fast packet message to be sent are the sequence byte, which is in every fast packet message, and the next byte is the total number of bytes to be transmitted. The total number of bytes is only within the first fast packet frame and can be practically 9 to 223. The PGN is also denoted as fast packet for receiving devices to be able to read the sequence and total byte count. So why choose a protocol stack instead of development? Well, it's in the title, to speed up development. The Warwick control stack has variables for the mandatory PGN's signal field values, like address claim, product information, configuration information, and heartbeat. So your wanted value can just be entered. There are handy macros for the starting source address and other more CAN-based areas of the stack. As well as probably the hardest part to develop, out-of-the-box functionality to receive the commanded address message, transmit and receive BAM messages, the ability to implement RTS/CTS message communication for clear to send, and transmit and receive fast packet messages. To implement the functions just talked of, it's mainly defining the messages to be sent or received via the chosen method, i.e. RTS/CTS, fast packet or BAM, with a few other slight tweaks. Not years of coding to get the functionality of the lower level parts of the stack that understand the multi-packet message timeouts or fast packet sequence bytes or commanding the device's address, as this affects the address claim process. And oh yeah, did I mention the stack looks after the address claim process as well? So no need to implement that functionality either. So in development hours, which is money, which is time, which is effort, what you purchase as a current stack would easily cost $100,000 in manpower to develop. So not only speed in development, but being very economic at the same time. So let us break down what parts of the NMEA2000 and J1939 protocols are pre-implemented or very close to being ready to go out of the box. The stack will handle the dynamic address claim process, respond to an ISO request for address claim, product information, configuration information, and the transmit and receive PGN lists. The commanded address is already implemented. It has the functionality to send and receive BAM PGNs or broadcast announce messages, the ability to send and receive connection management data transfer PGNs or CMDT with the request to send and clear to send. And then the heartbeat PGN is implemented. You just need to enter your device's signal values. The stack also deals with complex requests for address claimed, an example implementation for complex commands, as well as CAN error frame monitoring. We also offer the production of HALs or CAN drivers for the customer's wanted microcontroller or hardware. Please get in touch with sales@warwickcontrol.com for more information on this. We can perform the NMEA2000 certification testing service to get the NMEA2000 certified status, or a pre-test service to make sure the device is acting like it's going to pass the certification test, to avoid a full price test run with lots of failures, as well as written feedback on any failures and how to resolve the issue. We also provide a Warwick Control Technologies interoperability test with the full price test as extra value. This tests scenarios like a CAN shorted to ground fault for CAN high or CAN low to check the device recovers. With either a full price test run or a pre-test run, we'll give feedback on the failures. So here's the stack functioning on the STM32 board with X-Analyzer. As you can see, there's speed water referenced, and engine parameters dynamic being produced as a reference design. Then there's an ISO request for address claim, an ISO request for product information, and then an ISO request for configuration information, a complex request for address claim, and then the commanded address, changing source address to 06. And then if we edit the transmitter, we can change the source address back to 05 again, as we see the 05 messages update. Then there's obviously the scope to plot the signals on, the gauges to view them on, and on the NMEA2000 messages tab, the plus button drop down to again view the signals. And there we see the heartbeat PGN implemented. So thanks for taking the time to listen today. Please get in touch with sales@warwickcontrol.com for any questions you have. If we've convinced you already about the NMEA2000 stack, then drop us an email or phone call and we can discuss further about the needs for your project. And please don't hesitate to get in touch with any questions. Again, thank you for your time, engineers and developers of the marine world, and have a great day.